Welcome to our learning session. My name is Jordan. I'm going to kick things off, but my colleagues Adam and Peter are going to take over and cover some things as we go through. But today we're talking about the democracy palette. I'm super excited about this one. I think it's super cool. Just being in the Web3 space, I'm super excited to see like how we can start to govern things actually on chain and make decisions as collectives to realize this like DAO kind of future. And Democracy Palette is one of the things that is allowing that to come to fruition. So if we can just jump to the next slide here. Here we go. Here's the agenda for the talk today. We're gonna start very high level. We're gonna talk about what the Pallet's purpose is and some terminology that we're gonna use as we go through. And then we're going to go through the proposal lifecycle. Then I'm going to pass it off to my colleagues, and they're going to talk about the dependencies and what connects into this palette, the things that are required for it to work. Then we're going to do a demo and a code walkthrough. And without any further delay, let's jump right into it. All right, so the democracy palette's purpose. When we first started talking about this as a team, this was kind of like the first thing that came up is like, democracy, what does that really mean? And one quote, I think it was Abraham Lincoln, I've modified it here a little bit. He said, governments of the people, by the people, for the people shall never perish. But I've changed it a little bit to governance to suit Web3 and updated it a little bit. So what does that really mean though? Like, how are we able to do that in a decentralized way? And so we use tokens. Basically, we consider you a person or of the people if you are a token holder, and we use these tokens to give you voting power. We use these tokens to give you a voice in democracy. And what else does this palette allow us to do? It allows us to make decentralized decisions on how we can spend treasury funds. So we have a pot of funds that belongs to all token holders. How do we decide where those funds get distributed? We use the democracy palette for that. Another really cool aspect of the democracy palette is that it allows us to enact forkless upgrades to the runtime. And I don't know that any other chain that is able to do this, but we can use this democracy palette to govern the new upgrades to the chain, and we do that in a fair and democratic way. Some other common use cases for the democracy palette is if you're looking on Kusama right now, there's a lot of HRMP channels being opened, so we can do cross-chain communication, as well as I mentioned before, managing requests for the treasury and runtime upgrades. Okay, so some of the terminology that we might use during the presentation here, just to demystify them for you. But if we say anything again that you don't understand, please drop it in the chat, and we will cover that so everybody's on the same page. But one of the first terms is a pre-image. And a pre-image is essentially a hash of the proposal. We'll see more specifically what that looks like in the demo, but this is a mechanism by which we can verify to a higher degree that what a proposal says it's going to do is the actual code that is going to be executed. And a proposal, as you might guess, is a proposal. It's a suggestion for an upgrade to the chain, and these proposals can come from a couple different directions, which we'll get into in a second. A referendum is what a proposal becomes once it's selected from one of the proposal queues. Again, this will be a little bit more clear in a second. And once a referendum is put up for a vote, then you can cast your vote either A or nay, or you could abstain, I suppose. Conviction is a cool mechanism by which a person with any amount of DOT can, using a locking period, can multiply the effectiveness of their vote. So the longer they are willing to hold, to lock in their tokens for, the stronger their vote is going to be. And if for whatever reason, a person doesn't want to pay attention to governance and vote on every referendum, they are able to delegate their vote to another person that they trust to vote in their best interest. And so that's called delegation. And then there is an enactment period. This is the point where after a vote has been realized, whether it's a or nay, then there's a period of time in which the people in the community have a chance to exit essentially the community before the vote gets enacted. And so that's called the enactment period. And then the lock period, as I mentioned before, was the amount of time in which the tokens are going to be locked for, that based on your conviction, as well as the duration of the proposal, or the referendum rather. Okay, here's the life cycle of a proposal. So some person has a brilliant idea and they say, hey, we want to make this addition to Polkadot or Kusama. I want to submit a proposal. They can do this in one of two ways. If they are amongst the elevated class of a council member or a technical committee member, then they are able to add this to the council queue. Otherwise, if you're just a regular old token holder, you can add your proposal to the public queue. And then every voting period, one of these one of the proposals from either of these queues, it alternates every voting period. A new proposal is added from the other queue, and it's determined based on the amount of seconds that a proposal has. So a person puts up a proposal and they lock some dot saying that they want this to be enacted, and other people can come along and say, I agree with that, and they can match that amount of tokens that a person locks and second the proposal and add those tokens to the overall bonded amount for the proposal. That continues for until the new voting period starts, and then we choose the top voted or the top bonded proposal to become a referendum. A quick side note here, there is another way for a referendum to be created, and that is in extreme circumstances through some coordination between the two councils, the general council and the technical committee. They can propose emergency referendum and fast track those and get them put into the referendum queue outside of the normal process. Once a referendum has been put up, then it enters the voting period, and the voting period varies from chain to chain. In Polkadot, 28 days. Kusama's 8 days. In other chains, this is a configurable value. You can change that to your needs. During the voting period, you're able to lock your dot. And this is where conviction and adaptive quorum biasing comes in. And I'm going to talk a little bit about that in a second. And also I wanted to mention here Polk Assembly, because it's a pretty critical part of governance, where essentially it's a third-party site where you can go and view information about a proposal. The write-up, the actual, parameters of the code that is going to be enacted, all of that sort of thing, as well as comments. This is a super important part of a kind of democracy. We want to debate and have opposing ideas kind of cancel each other out so that we rise to the surface with the best kind of solution. And Polk Assembly is where that can happen. Discussions can happen all the way from a proposal being initially proposed all the way up to it becoming a referendum and while it's being voted on. So it's a super important part to mention there. But during, provided everything goes well during the voting period, we will come to a point where the voting period ends and we find out whether the referendum passed or failed. And if the nay votes have it, then, well, as you guessed, nothing would happen. But if the aye votes have it, then we enter what's called the enactment delay. That is the point in which people have a chance to exit the community if they didn't like whatever the proposal was going to add, and so they can leave. This is also a point at which the council can step in if, for whatever reason, the community let through a very dangerous proposal or referendum that would do something terrible to the chain, and the technical committee and the council realize this in time, and they have the ability to cancel this, but it is I don't think this has ever been done, and it's like a super break glass in case of emergency type of situation. But provided that doesn't happen, then the proposal will be enacted. And again, I don't think I can overstate this enough. It's such a cool mechanism that we already have the code ready on chain, ready to go, so that as soon as the enactment delay finishes, the scheduler pallet will deploy the code to the runtime, and it is kind of like automatically happening. I just think that's an amazing part of the whole governance process here. Last couple of things I wanted to talk about was conviction and adaptive quorum biasing. These are kind of novel concepts that Polkadot has implemented, and it's worth mentioning here. So conviction voting is the ability to lock your tokens for an extended period of time in order to gain a multiplier to the strength of your vote. So if you really believe strongly that we need this runtime upgrade, you can lock your vote for 56 days, and you'll get a 2 times multiplier to the strength of that vote. And essentially, you can double the amount of days which are equal to the voting period. So again, on Polkadot, it's 28 days. Kusama is 8 days. So every time you double that voting period, or the amount you're willing to lock your tokens for, you'll increase the multiplier for your vote. This also gets applied when you're delegating your vote as a side note. So you can apply conviction and delegate your vote to somebody else, and that multiplication will still be applied. Another kind of trickier thing to wrap your head around is adaptive quorum biasing. So this is a way by which we can kind of combat the fact that sadly not a lot of turnout happens in on-chain governance, at least not yet. It's very common for less than a couple % of the total token supply gets applied to any referendum. So in these cases, we've added this adaptive quorum biasing that essentially help us pass proposals when there's a low turnout, but we have a high degree of certainty that this is something that we need in the chain. So to kind of dig into that a little bit more, if the public, if a proposal comes in through the public queue, then it will have a positive turnout bias. If the council has a unanimous agreement when they add a proposal, it'll have a negative turnout bias. And if the council has just a majority agreement, it'll have a simple majority bias. And the chart at the bottom here kind of explains what that means. So if there is a positive turnout bias, that means that if 25% of the total token holders come out, that means we need 66% saying aye for something to pass. Whereas in negative turnout bias, it's the opposite. So in positive turnout bias, we need 2/3 for it to pass. In negative turnout bias, we need 1/3 to pass. But in all cases, as we move towards 100% participation, it becomes closer to a simple majority. So this is a mechanism by which we can kind of mitigate the negative effects of a low voter turnout. I know it's kind of an abstract kind of concept to wrap your heads around. I still have a difficulty figuring out positive versus negative turnout bias, but all this information is on the Polkadot wiki to reference and go back if you need to. Yeah, I'm finishing up there, and I'm going to hand it over to my partner Adam to take it from here.
Yeah, I'm taking over the microphone. So I will have a word about the dependencies. And by dependencies, I mean your other frame pallets, libraries that are used by the democracy palette. First remark I would like to make is that all of this is trade-based dependencies. For those of you who understand like what are trades in Rust, this should be pretty easy to understand. For other folks, it's like basically depending on the interface, the contract, not the actual implementation. But as you could easily imagine, there are many alternatives, like a multitude of implementations of a single interface, but that could obviously change in the future. So I have listed here a bunch of interfaces, and I have also added comments like for which particular features are they used. Deposits, I mean, you've heard about locking tokens, like depositing some amount of currency when submitting a proposal. So all of these requires currency trade, which is implemented by the balances palette. It's a pretty commonly used palette. Many other applications. Then there's special privileges. You have Jordan talking about the technical committee and the council, which are like some governing bodies who can do more than the general public. And for this particular feature, ensure origin trade is used, which has two implementations. One is Pallet Collective, which allows for collective bodies such as the mentioned technical council and the technical committee and council. And there is also Pallet Pseudo, which allows for like an authoritarian rule over some of these decisions. You can combine the two using some clever logic. So like for some particular situations, you could use pseudo, for others collective. When there is a collective, you could also specify the config, like the required rate. Now we have schedule named, right, which is used for actually enacting these proposals. So democracy basically handles all the voting stuff, but once a proposal is voted on and it gets accepted, it needs to get actually enacted, executed. And for that purpose, we need this schedule named trade, which is implemented by the scheduler palette. And last but not least, there is slashing involved, like when somebody is proposing stuff that gets rejected, or some proposal gets blacklisted. If I recall correctly, then the stake is slashed, and for this there is a trait called unbalanced, which is implemented by Treasury Palette, about which my colleagues were talking last week. So you pretty much should know what this means. But just to briefly recapitulate, it means that like whenever everything is some stake is slashed, it goes to the treasury, and later we can vote what to do with this money. Now, I will also mention Polk assembly here. It's not strictly a dependency, but it's a related piece of code, and it's quite important. As Joran previously mentioned, this is a kind of interface, like a subsidiary interface for democracy. And in the referenda tab, you can find discussion and lots of information about particular proposals, which is important because the proposal code itself might be, not understandable for everybody, and every token holder is invited to participate in democracy. So that makes things easier by having some kind of natural language descriptions and discussions about proposals. And now, in a moment, I will show you a live demo of the democracy palette. But before that, I wanted to sum up what I will be showing. So this demo will be presented on a specially prepared node running in development mode. So it will be like a single node, producing blocks, not any kind of free network. And the proposal that we will try to enact is a very simple one. It would be to just mint some money and give it to some account, set the balance of some account to a non-zero number. That's it. And step by step, it will go like submit a pre-image. Pre-image is the content of the proposal. Then submit that proposal, linking to that pre-image. Then back the proposal so that it becomes a referendum. Then vote, and then we will hopefully see the proposal enacted. So here is Polkadot.js interface. It's not showing anything yet because I haven't started my node yet. Okay, there we go. You can see that the blocks are being produced. So first, let's take a brief look at the accounts. You could see some test accounts here: Alice, Bob, Charlie, Dave, and so on. You can also see here in the balances column that some of them have money and some don't. So the proposal will be to give Dave some money printed out of thin air. While being on this page, we can already use one feature of the democracy palette, and this is called delegation. So let's say that Alice, she really trusts Bob, and she would like to delegate some voting power to Bob. So I'm selecting the delegated account here. I will give 1 million with 1 times lock duration, sign and submit. And that's it. It's added. Now let's go here. You can see that the Polkadot.js interface provides us with a special menu here, tab, called democracy. And here we will be able to submit our pre-image proposal and then do the voting. So let's start with the pre-image. Bob will be proposing to set the balance of Dave's account to some big amount. You can see here that I am able basically to select any pallet and any function from it, and explicit to be called. Here in particular, I'm choosing to set the balance of Dave's account to some new amount. Here is a pre-image hash, which I will copy because this hash will be important later for submitting the proposal. Okay, so now the pre-image is submitted. It's time to submit proposal. Here I am pasting the hash that I have just copied, and I will need to lock some balance. The minimum deposit is pretty low, like 1 nano, but it's just a test network with very low fees overall. So it doesn't really matter. In real world example, that would be much higher probably. And now, as Bob, I can also endorse my own proposal so that it will become a referendum. Now we need to wait for 32 more seconds because there is this thing called launch period here. It's set to 2 minutes for this test node. And in real world, like for Kusama, I think that's 14 days, and for Polkadot it's 28 days. So yeah, I'm glad we don't have to wait this long during that demo. In the meantime, we can check that in Bob's account, we see that there is some reserved currency. You can see here that I had to reserve 1 unit for submitting the pre-image and then for supporting my proposal. Now let's go back to the democracy over there. You can see now that there is a referendum. Everybody can see it, and everybody can vote as long as they have tokens. Here in the drop-down, we can see the details of the referendum, like what will happen if I vote yes, what will happen if I vote nay. And let's cast a vote then. Bob obviously supports his own proposal, and he will vote aye. Now, as the vote has been cast, you can see there is this green tick. There is 100% support, so this means if nobody votes nay, it will pass by the end of the voting period. But here comes, let's say, Charlie, who's like, no, we shouldn't really, create money because we will cause huge inflation. And he decides that he's going to lock this for twice as long because it's really important to him. And there we go. Now it's 50-50. So the referendum would not be approved, but we want it to be approved because we want to see the proposal enacted at the end of this demo. So let's say I will change Charlie's vote to aye. So we can finally see the proposal being enacted. All right, we need to wait 54 more seconds. It does take some time. I can show you one more thing in the meantime. Like, let's say Alice, she doesn't trust Bob anymore, so she can undelegate her votes. And once this is done, and we go back here, you could see that the number of votes here is lower because it's only like Bob's 1 times 1 million units without all the support from Alice that was there previously. 6 seconds more, just 1 block, and it will go to the dispatch. Okay, so now there's the enactment period. I have set it to only 30 seconds, not to bore you. So you can see there is like a proposal enactment scheduled here. If there was a technical committee and they, in the last minute, occurred to them that it's a really bad proposal, that they could veto it probably here. But if nothing bad happens, in 6 seconds, you shall see it enacted. So let's go back to the accounts palette, and we can see here that they actually got some money. So that concludes the demo.
This is the mid conclusion because we're going to move into the code walkthrough right now. So if folks don't want to stick around for that, this is my my soapbox speech to say a couple things. So it's worth mentioning that Governance 2.0 is on the way, and it's going to change a lot of things, like we just discussed. The technical committee and council will be phased out and kind of replaced with a new fellowship idea. The restrictions of Governance 1.0 have become evident. that proposal throughput is slower because we only have like one slot for a proposal at a time, and for Polkadot it takes 28 days for a full cycle, so we can only really like put through 12 proposals a year, which that seems pretty slow. So I believe the idea with the with Governance 2.0 is there's going to be multiple tracks so we can increase the throughput. And yeah, so that will be a massive improvement. And the last kind of call to action is Polkadot doesn't want you, but it needs you. It needs you to go out and vote to safeguard the system. The only way that we're going to make it in this crazy world of chaos is if we band together and we share our ideas and we vote for the things that we care about with conviction. We put our money where our mouth is, and we lock it in. So that's my call to action. And with that, we're gonna take a deep dive into the code. So take it away, Peter.
So the first thing that we will go into is how Polkadot has actually configured the democracy palette on the Polkadot chain. And then after that, we'll kind of just, if we have some time left, we'll dive through some cool parts of the code. But the first thing, we can walk over is the parameters here. So it's, the democracy palette is very configurable for a lot of different use cases. So you see all of these here. So we've got like the launch period, it's 28 days. This goes back to it being very slow. We've got voting period, also 28 days, enactment period, all of that is kind of fit together in 28 days. You can do like an instant allowed if that's true or false. So you can make it so maybe somebody could not put like a emergency referenda through or like an instantly enacting a proposal. And let's see, so then down here, I think this one is kind of an interesting thing to point out, is a proposal is just a call to another pallet or to an extrinsic. So that is kind of always what a proposal will be. And then also down here, like with these external origins, these external majority origins, all of these are in Polkadot, a lot of them are actually collectives or a root account. And in the case of Polkadot, there is no pseudo account anymore. So it's really just the system that can do that. But with these collectives, which we'll talk about, or not, we'll present next week, is this collective palette. And in this case, this is, you kind of think of it like a multi-sig, where if half of the collective votes, then the proposal will go through. So this is where the council comes in, the technical committee comes in. But of course, it is just where is it? It is just an origin. So this can be a lot of things. So if some parachain wanted it to be a pseudo account and they had a dictator, they could do that. But it could also be nothing. Like you could be, there could be no pseudo account on the chain and make it so that nobody can have a collective, and it can only go through the public proposals where everybody has to vote on it. And let's see. So it's very configurable. So we've got external origin, we've got fast track origin. And all of these have different kind of parameters on them. We have an instant origin, and it just keeps going. There's a bunch of them. There's an origin that can actually blacklist proposals if they wanted to. Veto origins. So this is, in the case of Polkadot, the technical collective. They can actually veto a proposal. However, it can only do it. They can only do it once for a proposal. And then over here, kind of tying back to the last presentation, is the treasury here. So if there's ever an invalid proposal, like say a proposal is going to be enacted, but then they can't actually submit the proposal, or the system recognizes that the pre-image is invalid, doesn't go to a proper extrinsic or a proper pallet, then that deposit will actually get slashed and it'll be sent to the treasury. And then of course the scheduler. This is a very key part of the democracy palette, because it allows it so that all the proposals enacted can be actually executed at a certain point in time, and it can do it kind of in a very decentralized manner. So that way, there's no centralized person that has to go through and kind of click through like, yes, enact the proposal. It's completely run by the system. Yeah, and I guess before I keep going, is there any questions on this configuration here? Anything you'd like to see? Awesome. Well, I guess I'll keep going. So, there's just some things that, as we kind of read through this democracy palette, it's very big. It's over 2,000 lines of code. There are some certain things that we thought would have been cool to point out. So let's see. First, kind of just walk through a little bit about how in the code, submitting a proposal would look like and voting on it. So first we have this propose function, which really doesn't have anything too special going on. We reserve the deposit. So everybody that creates a proposal has a deposit that is taken from them and stored. So that way, say the proposal is invalid, then that is slashed. Otherwise, it's returned to the person who presented the proposal. We, insert the proposal into the system. So now it actually exists. And of course, kind of alert the Polkadot ecosystem or the Substrate ecosystem with this event here. And then you come a bit further down, and this is the second. So when it's in the proposal phase, you don't vote on it, you second it. And this is, everybody who seconds a vote also has a deposit that is taken out. It's reserved for the system. And it's just kind of, it's upvoting a proposal, essentially. It's just like, yep, I agree with this, and they second it. Now, once there's enough seconds on a proposal, it moves up to a referenda. But there's actually, unless you get into fast-tracked origins and things like that, there's no extrinsic that any normal person can call that will update a proposal to a referenda. So this is something that I find kind of cool. It's a cool way to implement it. Is all of the proposals that move up to referenda all come through this onInitialize hook right here. So basically, at the start of every single block, this onInitialize hook will be called, allowing the system to run a specific function that they desire. In this case, for democracy, it's this begin block one, and it passes in the current block number. So go to this. And what this does right here is when, if it's time, if the launch period is at 0, so say in case Polkadot 28 days is up, then this will be called, and it will find the proposal with the most amount of votes or seconds, and it will actually upgrade it to a referenda. And this is really, excluding fast track and pseudo accounts and all that. This is the only way to actually do that. It's the only way for proposal to go to referenda. Now, the same thing happens with actually calling a referenda. Once again, unless there's a fast track origin, the only way to call a referenda is through here to actually execute the referenda. So what this part does is we actually take all of the referenda that are ending at that specific block, the one that was passed here, this now. So all of the referenda that end at this specific block will be, we'll loop over it, and they'll be baked. Essentially, it'll be scheduled. Now, there is a measure in place to make it so that way, not too many referendas are scheduled at once, and that's this launch period right here. Basically, you can only have a certain amount of proposals in a specific launch period, and that launch period is, delayed. So unless there's a proposal that was upgraded to referenda, you're not going to get a bunch of referendas called 5 different pallets scheduled in one block time. But this big referenda, let's go to it. So over here, if there's no delay in the referenda, it'll be enacted immediately. This will actually, there's no scheduling, it's enacted right away. However, for the more common use case where most proposals and referenda actually do have delays, it'll actually come down here and it will be scheduled. It'll be scheduled for an amount of time here, which is usually, I think, I'm not seeing it now, but it's usually over here where you've got this enactment period. So the proposal won't be enacted until after the enactment period. As they mentioned earlier, where this is, say somebody wants to remove their vote or step out of the system because they really don't like it. That's kind of this delay there before the proposal is actually enacted. However, once that enactment period is done, everything is good. It will be scheduled and it'll be executed in that block. And like I said, really, unless you're talking, unless there are fast track origins or anything like that, the only way to get here is through the system, going on initialize and stepping through these functions. Now, of course, there are some, let's see, let me go here. So like right here, enact proposal, if there is a pseudo account in the system, this can be called. So somebody could fast track it, initiate a proposal right away, and nobody would really have a say. In the case of Polkadot, though, there is no sudo account. It's all through the collective. So there would have to be a couple extra steps, like through the fast track origin or through like the emergency collective.
Well, with that, and I thank everybody for tuning in and participating.